By default, a switch has all of its ports in a single broadcast. This means if a broadcast is sent, it will go out to all ports save for the one in enter on. Following that logic, to create separate broadcast domains, an engine would have to use a different switch to each domain, which isn't practical or scalable in any real way. This is where virtual LANs or VLANs come in. VLANs allow logical segmentation within a single switch. A VLAN allows for multiple separate broadcast domains to exist in the same switched infrastructure. VLANs have many benefits. They reduce the number of devices that needlessly receive broadcasts. They increase security by segregating networks, and they also shrink the file domain so troubleshooting issues can be simpler. Managed switches or those that allow VLAN configuration generally default to have all ports configured for the default VLAN. In Cisco kits, this will be VLAN 1. As a best practice, all ports should be moved to a VLAN other than one for security reasons. For example, being the default VLAN, an administrator can't delete VLAN 1. A VLAN is created from global configuration mode by specifying the VLAN ID. In this example, I will configure VLAN 10. Configure T, that means configure terminal, with VLAN 10, this command to choose the number 10 for this VLAN. The VLAN has technically been created and can be used, but best practice is to give each VLAN a useful name, like name user data or user data. I will also create a VLAN for VoIP traffic, VLAN 11, name user VIP. Now that the VLANs have been created, I will assign them the same user ports. In this example, I will configure ports 1 and 2 at the same time using the command interface range command. Interface range command normally I can type directly interface range fast 0/1 to 2. That means fast Ethernet 0/1 to 2. By default, every switchboard is configured as dynamic auto. This means it will try and automatically determine what the ports at the far end would like the mode to be adjusted to. I don't like surprise in my network, so I always adjust ports mode to be accessed. This is done with switch port mode access. An access port is what a standard device is connected to, something like a PC, printer, router, in a sense, an end device. The access designation tells the switch to strip the VLAN tag of a packet as it leaves this port and to place it back on as it enters. VLAN tags are actually placed in the frame header using various different senders, but the one the CCNA focuses on the most switches use is 18.2.1q. A tag is just a number that represents how the VLAN is identified inside the switch. The VLAN tag for my user port will be 10, as that's what I will configure it for user data. The access VLAN is assigned to a port with switch port access VLAN 10 command. To verify your VLAN database, I can verify active access ports and configure VLAN with the show VLAN command. Cisco also has a special configuration option for the web solutions called Voice VLAN. This allowed a port to have an additional VLAN added to it so that if a Cisco phone is connected to the port, it will automatically have the phone traffic moved to the special voice VLAN. This command is actually pretty easy to implement. I will use configure terminal or config t interface range to specified interfaces. I will use here interface range fast 0/1 to 2 and the special command switch port voice VLAN 11. Now any of my Cisco VO IP kit will automatically be segregated from regular user data. I will utilize VLAN in every network I have ever built, so it's no surprise that I will be heavily covered on the test.